In this video, we will learn about the basics of AWS data pipeline and its benefits. Currently, one of the bigger challenges for businesses is to manage their data and integrate it for optimized processing and analysis across various AWS computational and storage services. To tackle such challenging demands, AWS Data Pipeline enables the movement and processing of data between different AWS services and between other data storage sources very reliably and at specified regular time intervals. With AWS Data Pipeline, data can be accessed from the location stored, it can be transformed and processed even at very large scales, and then the processed data can be sent to the desired storage services such as Amazon S3 or Amazon DynamoDB. The whole data management and processing workload through the AWS data pipeline is extremely reliant. It has a scope for tolerating faults and is repeatable and is easy to use with fairly simple drag and drop console within the AWS interface. Now, let us discuss some of the AWS data pipeline benefits. As AWS data pipeline allows users to create reliable and customized data pipelines, it also enables all data movement tasks to be automated. Therefore, it allows users to eliminate resources and easily manage any inter-task dependencies. It is highly scalable, allowing data interactions happening in series or parallel across single or multiple machines. Also, it is inexpensive to use and optimizes cost for users. Let us now see in theory how to get started with AWS data pipeline. To get started with an AWS data pipeline, first a pipeline definition needs to be created, which helps communicate business logic to the service. This definition is created in a pipeline definition file. The file usually contains the names, location, and formats of the data sources. Moreover, it may also include activities needed to perform data transformations, the schedule of those activities, any preconditions, or any resources that are needed to execute these activities. Lastly, it may also include any actions to alert when certain conditions are triggered or met. This pipeline definition can be created graphically using a simple interface on the AWS console or by writing a JSON file in the format used by command line interface. It can also be created programmatically using AWS Data Pipeline APIs. Lastly, let us look at AWS Data Pipeline use cases. One of the use case of data pipeline is to be able to analyze unstructured data from logs using Hive, combining this with existing structured data from RDS, and then uploading everything to Amazon Redshift for querying and analysis. Other of the use case could be to copy tables from DynamoDB to Amazon S3, perform transformations, and run analytics using SQL, and finally load the data to Amazon Redshift. Thirdly, one use case could be to copy data from RDS or Redshift tables to Amazon S3 and vice versa. Lastly, it is frequently used for backing up DynamoDB tables to S3 and also to copy data from users' local storage warehouses and moving it to Amazon data stores to make it available for various services. In this video, we will create an AWS data pipeline to copy a CSV data file from Amazon S3 to another bucket of Amazon S3. In the activity of the data pipeline, we will create a trigger to allow for the task repetition at same time every day. And then in the activities of the data pipeline, we will add a notification system that will send an email on successful completion of the data copying activity. For the entire exercise, we will use an EC2 instance managed by AWS Data Pipeline for the copy activity. So let's get started. First, let us search for data pipeline in the top search bar to look for AWS Data Pipeline console. Let us open the first search result to access the AWS Data Pipeline console. Since we don't already have a running data pipeline, we can click on Get Started Now button at the center of the screen to access the console. In order to successfully create the pipeline, first let us enter the name of the data pipeline in the name field. We can name the pipeline as Copy Data from S3. In the next text box, we can write the description for this pipeline. However, writing the description is optional, but it's helpful for easy identification, especially in a team setting when someone else could have access to the same pipeline. For now, let us leave the description option as is. In the next step, we have to choose the source of the data pipeline. To configure the source, we have three options. One is to build using a template. The other is to import a definition file. And third is to build using an architect. For our case, we will be building using an architect. But before we proceed with that, let's check out some options that we have under build using a template. Under different templates, we have different options where we can use AWS Data Pipeline to import and export DynamoDB data, or we can export data from SQL Server running on RDS to Amazon S3, or we can copy data from Amazon Redshift, and many more such options. But for now, let us select build using an architect as our option. In the next section, we can set up the schedule for our data pipeline. Under Run field, we can select on pipeline activation, or we can set up our own schedule. For our case, we can set up our own schedule. We want it to run once a day. We want our pipeline to start at the activation of the pipeline, and we want to end our pipeline after, say, 7 occurrences. So that will be equivalent to 7 days. To allow for that, let us edit the text box from 1 to 7 occurrences. In the next step, we can configure the configuration for logging. We can let the logging be enabled. However, we would have to provide an S3 data path where our logs will be stored. We can set up this path under S3 location for logs text box. For that, we can click on the folder next to the text box. From here, we can choose the bucket where we want to save our logs. To allow for that, we already have an S3 bucket that is named as logs for CSV data pipeline. We can select that and click on select option at the bottom right of the window. Under security and access fields, we can leave the IAM roles set to default. Next, let's click on the Edit in Architect button, the blue button at the bottom of the screen, to proceed to the next step where we can configure our data pipeline in AWS Architect. At this step, our pipeline seems to be created but not activated. Before we can activate the pipeline, the first step in the architect is to configure an activity for our pipeline. In order to add an activity, let's select the Activities panel on the right pane on the screen. To add an activity under this panel, we can click on the Add button on the left pane. Under the Add drop-down, we have many activity options. Let's select the Copy Activity option. This option adds one activity configuration setup under the Activities panel. In order to successfully set up the default activity, let's configure the settings under the default Copy Activity 1 header. First of all, let us rename the field from default Copy Activity 1 to S3 Copy 1. In the type field, the copy activity value is set up correctly, so let it be that. Let us now click on the drop-down next to the output field. Here we can select Create New Data Node option to set up an output node for our copy activity. Similarly, for input field, we can repeat this step. Since we want to run the data pipeline activity every single day for the next 7 occurrences, we can let the schedule value of every 1 day be as is. Finally, under the Activities panel on the right pane, we can click on the last drop-down that is available to us to add any optional field. Here, we will select Runs On value to add a Runs On field into our Activities panel. Under the Runs On field, we can click on Create New Resource option. Similarly, we'll add another field that is On Success. Next to the On Success field, we can create new action. Once our activity panel is set up, we can view the graphical representation of our activity panel on the left pane. We can zoom out on the activities panel by clicking on the zoom out button. Similarly, we can zoom in by clicking on the zoom plus button. Also, do note the arrow markings in the graphical representation as they help distinguish between inputs and output steps. Now moving onto the right pane, we can select and configure the data nodes configuration. This will include input data node and output data node. First, let us configure the default data node 1. As we can see from the left panel, the default data node 1 is our output data node, so let us rename accordingly. In the type field, we will select the appropriate type of this data node. Here, we can select S3 data node. The schedule field of every one day will stay as is, and we can add an optional field. Here, we will add the file path as a field so that we can input the file path of our output data node. In the file path text box, we need to add the path of the S3 data node where the outputs will be stored. For that, let us head to S3 data node and copy the file path. Once the correct file path is copied, our out S3 data node configuration is set up. Next, let us move on to default data node 2 configuration. As we can see from the graphical representation on the left pane, that this is our input S3 node for the copy activity. So let us rename that accordingly. As we did for output node, let us select the appropriate type, that is the S3 data node, and add an optional file path field. To add the correct file path, let's head to S3 console again to copy the path. With this, we finish setting up the configurations for data nodes, so we can collapse the relevant column. As the column is not collapsible, we can proceed to the Resources panel to configure our resources. As a first step, let us give an appropriate name to our resource. We can call it Data Copy Compute. Under Type field, we can select EC2 resource type. We can leave the role and resource role fields as default and proceed with the schedule field. Since we are running the data pipeline once every day, the value in the schedule field seems appropriate. Let us see if we want to add any optional field. At this time, there is no other resource field that would be required to be configured. However, we can come back and edit the pipeline in the architect. So let us proceed to the next step. Under the Others panel, we will configure the notification action. Let us give an appropriate to the default action. We can call it Send Me Email. Under the Type field, we can select SNS Alarm. Here, SNS stands for the Amazon Notification System. To successfully set up the SNS, we'll have to fill a topic ARN. We've already created a topic in AWS SNS console. We can just head to the SNS console to copy the ARN for our topic. In the message field, we can add the email message that we would like to see. So we can write an appropriate message. Here, I will write copy task completed. Similarly, in the subject field, we can add an appropriate subject to the email. Here, I will write notification from data pipeline. Now our activities and objects in our data pipeline are configured. We can proceed and select Save on the top bar on the left pane. Once we successfully save the pipeline, we can click on the Activate button to start the pipeline. The Activate button is located next to the Save button. On saving, we will be alerted of any errors or warnings. If and when you see an error message, read the description along with it, and it should mention the object of the pipeline where the error is located. After resolving the error, you can click on the Save button again to see if there are any more pending errors. However, in case of a warning, AWS still can let you activate your data pipeline, but it's still a best practice to resolve your warnings. However, for our test case, let us proceed with activation of our data pipeline by clicking on the blue Activate button on the new window that's popped up after clicking the Save button. After clicking on the Activate button, we have come to a new screen. This screen allows us to monitor the activity of our data pipeline. On clicking the Refresh button on top right of the center screen, we can get the most updated updates. So let us do just that. We can click on the name of a data pipeline to expand to view its objects and resources. When the status of every resource in our data pipeline says finished, it would mean our pipeline has finished all its tasks. At this time, we can see that the status of the data copy compute resource is still under creating. So once this status is finished, we will get an email notification saying our copy tasks are completed. However, if pipeline does not finish running successfully, you can check the pipeline settings for issues. With continued practice or utilizing AWS resources in real-world use case, you can continue to explore different configurations and different options that AWS provides. In this video, we will understand the key differences between AWS Data Pipeline and AWS Glue. AWS Data Pipeline and AWS Glue are two ETL solutions offered by the AWS platform for users. As we discussed earlier, AWS Data Pipeline is the service that helps users to transfer data on the AWS platform by defining, scheduling, and automating all of these tasks while monitoring them from a single location. Whereas AWS Glue is the big data cataloging tool that allows users to perform ETL tasks on the AWS platform. To understand key differences between these two services, we will be comparing them on parameters such as pricing, infrastructure, use casing, and operational methods. The first of the differential parameter is pricing. AWS Data Pipeline charges fee of $1 per month per pipeline if it is run for more than once per day, else $0.68 if it is run less than once per day or just once per day. Additionally, users may be required to pay for any other resources that are needed. On the other hand, AWS Glue charges about 44 cents per data processing unit hour, which are billed at every second of use. It also charges $1 per 100,000 objects that are managed within the data catalog. Please note that these are the prices at the time of the recording. Given the dynamic nature of the pricing, these could be dated even next week. The second of the differential parameter is infrastructure. AWS Glue is a serverless service. Therefore, it does not need any infrastructure for developers to manage. Any scaling or provisioning on Glue is managed within the Glue Apache Spark environment. Whereas AWS Data Pipeline is not a serverless service like Glue, and typically you can define the pipelines and have more control over the resources being used. The third of the differential parameter is use cases. Glue is best used to transform data from the sources and store it at target destinations, allowing users to focus on ETL jobs as they do not have to manage or configure the computational resources. On the other hand, AWS Data Pipelines transforms and move data across various services while giving control over the computational resources that are needed to run the pipeline. The fourth differential parameter is operational methods. AWS Data Pipeline allows users to create data transformations by programming APIs as well as using JSON files. It is able to provide support for DynamoDB, SQL, or Amazon Redshift. On the other hand, AWS Glue allows built-in transformations while providing support for Amazon S3 and Amazon RDS, in addition to Redshift, SQL, and DynamoDB. It also provides support for the Apache Spark framework, including Scala and Python. In this video, we will learn about AWS Batch and its functionality and benefits. AWS Batch Service allows developers and data engineers to build efficient and long-running computational jobs that run asynchronously and automatically across various computational instances. This is handy when users need to run multiple jobs at a very large scale, especially jobs that have a large number of dependencies. To allow for such features, AWS Batch is organized into 4 different components, including jobs, job definition, job queues, and the compute environment. First of all, a job is a unit of work that is submitted to the AWS Batch service. Consequently, job queues are simply a list of work that needs to be completed by the jobs and enables users to define priority levels as well as to leverage multiple queues of jobs. Thirdly, a job definition is just a description of how the work has to be executed. It comprises of the memory and CPU requirements as well as providing access to other AWS computational and storage services. Lastly, the compute resources that run the job can be configured by the users along with the number and type or types of instance on which the job will be run. Moreover, AWS Platform also has a scheduler that evaluates when and where to run the jobs that have been submitted to the queues. Now, let us look at some of the AWS Batch benefits. AWS Batch is a completely managed service that does not require any third-party batch processing software or installation of any infrastructure such as servers. Secondly, it provides a simple and scalable solution to users to allow them to manage and monitor their batch computing requirements. It is completely integrated with the AWS platform, therefore allows users to run multiple jobs reliably, which in turn allows the users to access the management capabilities of the AWS platform for writing, retrieving data from multiple data stores such as Amazon S3 or DynamoDB. In this video, we will learn about the real-world applications of AWS Batch. We will discuss these in over two domains, namely financial services and life sciences. First, let us discuss AWS Batch Use Cases in financial services domain. Financial services have typically used AWS batch processing frequently for processing end-of-the-day trades, performing risk management analysis, or for fraud surveillance. AWS Batch helps financial services to minimize any human errors, improve performance efficiencies, reduce overall running costs by automating processes. Financial services typically have improved the speed and scalability of intense computational workloads such as pricing, market positions, and overall risk management by automating and scheduling these jobs. Moreover, trading desks are also constantly looking to improve their trading performances and positions by analyzing daily transactional costs and market performances. These tasks require large-scale batch processing of datasets from various sources after the end of day's trading, which brings us to our last point, where financial services also use AWS Batch to configure resources and schedule analytics and machine learning algorithms on financial data. Businesses use such algorithms to find any irregular patterns and to identify any fraudulent or suspicious activity. Let us now discuss how AWS Batch can be used in the domain of life sciences. One very important application of AWS Batch is in the field of drug screening, where it allows research scientists to efficiently discover and identify structures that are most likely to bind to a target drug. Using AWS Batch, scientists are able to configure resources and schedule complex screening jobs that enable them to obtain a deeper understanding of biochemical processes, thereby improving drug discovery and development. In this video, we will understand workflow design and how AWS step functions work. AWS Step Functions is a serverless service that allows users to orchestrate multiple AWS services for accomplishing tasks. Users can use step functions for creating steps in a process where the output of one step becomes the input for a following step. Although this sounds trivial, AWS Step Functions provides a very convenient and an automatic functionality for executing various tasks. These step functions allow triggering and tracking every workflow step and ensuring that steps are executed in the correct order. Moreover, these functions are capable of handling errors and have an automatic retry handling functionality, thereby making operational tasks more efficient. Now, let us discuss some of the benefits of AWS Step Functions. These functions can be used to invoke Lambda functions for running AWS jobs. They can also fetch or insert items from storage databases such as DynamoDB. These step functions have multiple benefits as they can help developers to create complex sequences of tasks very quickly using a graphical interface and with inbuilt operational controls. Users can build applications by swapping or reorganizing components without having to write customized code. They also ease the process of setting up queues and databases for communication between all serverless services and eliminates potential human errors. Now, let us look at some of the limits associated with AWS Step Functions. AWS Step Functions has a limit of 25,000 transitions in a single execution and a payload limit of 1 MB. The free tier, however, includes 4,000 state transitions per month. If they are exceeded, however, they are priced at $0.025 per 1,000 state transitions. Please note that these are the prices at the time of the recording. Given the dynamic nature of pricing, these could be dated even next week. In this video, we will learn about the real-world applications of AWS Step Functions. First of all, AWS Step Functions can be used to create machine learning workflows. The step functions can be used to coordinate various jobs that are required to build, train, and deploy machine learning algorithms. The step functions can be used to automate pre-processing of the data using AWS Glue. After the ETL job is run by Glue, the data can be sent to machine learning interface called Amazon SageMaker to train the machine learning models on the data. After which, when the model is trained, we can create another job to deploy the model for making predictions. Another use case for AWS step functions is to be able to orchestrate multiple ETL jobs. The step functions can be used to orchestrate multiple ETL jobs that involve a large set of technologies connected in a complicated workflow. The step function can also be used to coordinate multiple jobs on AWS Glue. For example, one of the jobs could be to process sales and marketing data from Amazon S3 independently, and another job to join these datasets. Another use case of AWS step functions could be media transcoding. The step functions can be used to coordinate tasks for analyzing image files immediately after upload. For example, after a photo is uploaded to Amazon S3, AWS Lambda can be made to be triggered to process the data immediately. Some possible tasks for triggering could include creating thumbnail images, extracting metadata from the image, or invoking Amazon recognition, which will detect objects and scenes or an activity within an image. Video, we will learn how to set up an AWS batch job by navigating through the AWS Batch console. What we see on the screen is the AWS Management console. From here, we can search for AWS Batch by typing AWS Batch in the search bar on top of the screen. The first search result displayed on the screen is what we are interested in, so let's open that. For this tutorial, we will use the standard batch console to set up our batch job, as this view would help us navigate different components of AWS Batch. The other option, however, is to use AWS Batch Wizard instead. The first step to set up the AWS Batch is to set up a compute environment. This compute environment is a set of compute resources that the batch will use to place its own jobs. To create our environment, let's navigate to Compute Environment link on the left column of the batch console. Here, let's click on the Create button located on the top right of the center table. Now, let us configure our compute environment by updating each setting one by one. We can leave the compute environment type as managed. This will create compute environment managed by AWS Batch that will automatically scale out and scale in as batch jobs are scheduled and compute capacity is needed. In the next setting, we will name our compute environment. We can type the name of our compute environment in the text box. Let us call this batch-job-compute. Under the same section, we can proceed to the service role dropdown. In this section, we can select batch service role if it exists in your account. Otherwise, we can select a new role. Since an existing role is available, we can select the same role. Let us now scroll down to Instance Configuration section. Here, we can choose an on-demand provisioning model where if we keep the virtual CPUs to 0, then we will not have any compute resources running when there are no jobs to be run. Otherwise, if we give any integer value greater than 0, then we will have to pay for that many instances at all times. So keeping the minimum virtual CPUs at 0 to avoid any additional costs, and configuring maximum virtual CPUs as 10. Similarly, we can configure other advanced settings by following other items under the instance configuration table. Leaving those settings as is, we can proceed to the networking section. By default, AWS Batch will select your default VPC. If your account does not have a default VPC, or you want to deploy your own batch compute environment on a specific VPC, then you can select it here. In our case, since the VPC is already set up, we can scroll down to the very bottom and click on the Create button located at the bottom right. Now we will see the created compute environment on our console. Since we must have clicked the Create button twice, it gives the following error. However, if you click the button once, there would be no such error. Now that our new compute environment is set up, named as batch-job-compute, we will now set up a job queue related to this environment so that the computed jobs can be scheduled on the resources configured on this compute environment. To set up a job queue, let's click on the job queues link on the left panel of the batch console. Now on the top right of the center table, let's click on the Create button. Under the job queue configuration section, we can give an appropriate name to our job queue. Let's call this first-job-queue. In the subsequent text box, we can give a priority of 20. Next, we can scroll down to the next section. The next section is read as Connected Compute Environments, where we can use a drop-down to select the compute environment. Since we have two available compute environments, let us go with the compute environment that we created in the previous step. That would be batch-job-compute. Once this is done, we can click on the Create button on the bottom right of the screen. By this stage, we have created a compute environment and connected a job queue to it. Now we can create a job definition for our job. Job definitions specify how the jobs can be run. To set up a job definition, let us first click on the job definition link in the left panel on the batch console. Then let's click on the Create button on the top right of the center table. Under the job definition configuration section, let us give the name to our job definition. We can call it as first-job-definition. The next setting asks us to choose a platform for which we are creating a job definition. Let's select EC2 for this. Scrolling down to other settings, we can see that AWS asks us for job attempts. Here, we can enter any number of attempts to be made to run the job should the job execution be unsuccessful. Here, we can write 3 attempts. Optionally, we can also define execution timeout value. Scrolling down to the next section, which reads as Container Properties. Here, we can set up an Amazon Linux as a container image and define the job we want to execute when our job is run. Here, we can use echo syntax to print a bash statement. Under the command text box, we can type in echo job run complete, wherein job run is under quotes. Additionally, we can pass some environment variables to our jobs by adding the key value pairs in the parameter section. For now, we will proceed with our current settings and click on the Create button on the bottom right of the page. Now that we have set up the foundation for our AWS batch, we can proceed and run one or more jobs. To do that, let's click on the jobs on the left panel of the batch console. Then, on the top right of the center table, we can click on the Submit New Job button. Again, first setting is to give a name to the job. Let's call this first-job. In the subsequent settings drop-down, we can select the job definition we created in an earlier step. Similarly, in the next drop-down, we can select the job queue that we created in an earlier step. We can leave the rest of the settings as default and click on the Submit Job button at the bottom right of the screen. At this stage, one batch job has been placed in queue and AWS Batch will take care of spinning up the configured compute resources on our compute environment linked to the queue. Now, we can proceed to the dashboard section on the left panel to see an overview of the job that we have created. The table in the center auto-refreshes after every 60 seconds, and you may be able to see your number of jobs transitioning through different stages until the job ends up in the succeeded state. Please note that it would take a few minutes for AWS Batch to spin up the required resources and to run your job. Now, I hope you can continue to add on more advanced jobs to test the limits of the AWS Batch that we have set up. Good luck. In this video, we will discuss the data engineering pipelines, including real-time data and video data. First of all, let us discuss the factors to consider when choosing a data engineering pipeline. The first factor is the reason for creating the pipeline, including the source of data and the destination of the data. The second factor is the data itself, along with the information about the data volume and whether the data is stored or is streaming data, and whether the data follows some structure or it's unstructured data. Finally, it's important to ascertain the use cases for the data. For example, is the data to be used for analytics or machine learning or to make a more informed business intelligence decision. Next, let us discuss the case for real-time data. In the case of streaming or real-time data, the pipeline structure typically consists of the origin of the data stream, parsing and filtering of the data into smaller individual events, and then filtering the reduced data set to events of interest for the particular use case. From there on, the pipeline structure consists of data transformation and then loading the data into destination data lake. Real-time data is collected from various sources, such as logs, mobile devices, or sensors, then is sent to stream processing platforms such as Amazon Kinesis. From Amazon Kinesis, data can be sent for data ingestion to a data lake. And as we've discussed earlier, data lakes are based on object storage services such as Amazon S3. Once the data transformation and data ingestion steps are successful, the processed data can be analyzed immediately using Amazon services or can be utilized for machine learning applications. Now, let us discuss the video data pipeline. Video data coming from devices is loaded to Amazon Kinesis video streams, from where it can be sent to Amazon Recognition, which is a machine learning service that analyzes the video streams and identifies objects, people, text, or scenes within the video. The processed video stream can then be sent directly to Amazon EC2 or Kinesis Data Analytics or Kinesis Data Firehose. Moreover, we can utilize other Amazon services to invoke other interactions as well. In this video, we will advance our discussion on data engineering pipelines, including batch processing and analytics. First, we will discuss batch processing. Batch processing pipelines make it easier for the users to manage and monitor batch processing jobs and scale the computational requirements based on the needs. As batch processing is integrated with native AWS services, it makes it easier to automate and configure resources required to manage complex processing pipelines. For example, using AWS Data Pipeline, data from an AWS data source or from a client's database is loaded onto Amazon S3 bucket in various formats, such as CSV from RDS or JSON coming from Amazon DynamoDB. This data can then be extracted and transformed using services like Glue or can be loaded into Amazon S3 bucket in its native format. The batch service can then be used to manage various batch processing tasks in such a pipeline. Next, let us discuss the analytics layer in the data engineering pipeline. Data in an AWS warehouse can be analyzed using Amazon EMR, which is a tool for processing and analyzing big data using open source tools such as Spark, Hive, Flink, and Presto. Data can also be analyzed using Amazon Redshift to gain new insights from it. Amazon Redshift is a cloud data warehouse that allows users to query and combine structured or semi-structured data across the warehouse using standard SQL. It also allows users to save results of the queries back to S3 data bucket for further analytics using services like Amazon EMR, Athena, or SageMaker. And after a successful data analysis, data from any of these processes can be sent to Amazon QuickSight for creating dashboards and gaining better visual insights. In this video, we learned about AWS Data Pipeline and AWS Glue. We saw a demonstration on how to create an AWS data pipeline. Then we learned about AWS Batch and AWS Step Functions, where we created an AWS Batch instance using an AWS Batch console. Thereon, we learned about real-time and video data pipelines, including batch processing and the analytics layer. In the next course, we will learn how to use Jupyter Notebooks with Python.